Just fun, except that computers are involved. I thought I'd show one thing that I did in the lively kernel that is something that I've been wanting to do for a long time. I've always liked kaleidoscopes, and this is just a web page. There's the URL for it. This was actually done in our lively wiki. So if you go to this control there, you can look at old versions and back up. I think I mentioned that. But for now, we'll just skip it. The idea is that this area down here represents a slice of a kaleidoscope. And then it's being constantly copied up into the kaleidoscope there, so you can edit it like that, which I thought was kind of cool. And one of the things I discovered along the way, without really expecting it, is that some of the nicest hearts you can make, you can make just by taking an ellipse on its side and splitting it. So you get to experiment with that, you know. Thought that was pretty cool. And this was around Valentine's Day, so I thought I'd make one of these for my wife and send her the link. And but I wanted to make the heart throb, you know. And so we have just the very beginning of a tile scripting system in there too. And so if you take, here's what I did. You can make a tile for one of these guys, sort of like in Morphic, and drop it there. And it gives you this little blob on the side, which you can click on. And that lets you find all the messages inherited from various classes. And here's morph. And one of the things that a morph knows how to do is to throb. You can sort of guess what the script is like. And then up here you can type how many milliseconds you want per tick. And then you can tell it to repeat. So anyway, that's what I sent to my wife on Valentine's Day. Okay. And the one other piece of the lively kernel that I thought I would show you is, let's see, is that going to work? Let's just find out here. There we go. This was, we did a version of the lively kernel that's on top of Java 2D. I thought that would be good since I work at Sun. And I had this whole wrap to sort of sell myself, which was, you know, we get it working all in the open web. It runs in every browser, but then we do a version that is in a Sun plugin with Java, and you can get to all the enterprise software. So it's the best of both worlds. And they were doing a demonstration of their latest work called Java FX Script. And they said, we want to be able to show people that you can do stuff like that in JavaScript at Sun. So we actually did. This here is, it's one of their sample applications, and it's designed to show off graphical stuff. So you click on the graphical effect here, and then you move this slider. This one does blur. So you can see you move that slider, and it blurs the image. I thought that was pretty cool that we could do everything that they could do. Plus, you know, we had the argument that, well, if you're showing this to somebody who asked you to write this application, they might say, well, why don't you put the slider right underneath the flower? So, you know, I said, oh, okay, we can do that. Just like that. And that's something they weren't used to, so they thought that was Some of them thought it was cool, and some of them thought, I don't know about that. And there's a story about that. Anyway, I just thought I'd show you that. And get rid of these guys, too. Move. And the cool thing is that all the old applications run here, just as in the regular system. And actually this over here, this is a Java browser put in our Windows, all scrollable, and I guess it even works that way. Except that I think that this was done in an early version, so the text isn't quite right, but you get the idea. And one of the things that I had wanted to do for a long time, let's see if I can do this. You know the piano keyboard in Squeak. So I just, since I wrote it, I thought it was fair to copy it. And I did this, and in the open web version, I haven't found any nice way to make sound, just easily. Although I'm sure it's going to be easy fairly soon. We tried things like these long URLs that encode the sound of every note, but anyway. So that all works because we've got Java under there that we can call for the MIDI synthesizer. And I thought that was pretty cool, and I was playing around with the fact that you could, rotate the keyboard at any angle. And I slipped, and the keyboard fell on the engine like that. So I thought, oh, that's cool. I wonder if if I try it on the black keys, So I invented a new musical instrument. Okay. So let's get rid of that. And then...
I got confused. That was still JavaScript?
Yes.
Calling out to Java, right?
Calling out to Java for the MIDI synthesizer. Yes, that's right. And actually, I forgot to say one cool thing about that. And the truth is that I actually had to make a change for this to work. But I just pushed my finger down on the mouse button. I was not moving the mouse. Consequently, no events were going in. So how do you do that? And so what I did, I put a rule in there that says, in what's effectively the morphic event loop, if there is a ticking script that has ticked, then you should send a mouse moved event with the same coordinates as you had last time. And that way, see, the engine is running by a ticking script, so it knows that at the end of that it should emit a mouse moved that isn't really a move. And then if somebody cares about that, they can field it. Okay, so this is my boat, and this is just, I like engines, and I was crazy enough to buy this steamboat from a guy who was retiring. And you can see there's the steam engine. It's a dory. It's like a big rowboat. This is the steam engine, and that's the boiler. And it's a very simple thing, but it's kind of fun. But the boiler is a big, kind of dangerous thing, and plus it's hard to get it going because it runs on kerosene, and if the wind is blowing, it's a mess. So I started to do a conversion for it to run on gas. But partway through that, I had this invention, which is to do a steam engine that doesn't need a boiler. So the idea here is to just make a very hot piece of metal on the top of the cylinder, and use something like an automobile fuel injector to inject water into it. And then over here you just have a servo whose job is to keep the metal at 800 degrees. So if it cools off, it turns the gas on. If it warms up, then it stops. So that's so as a result, I haven't done anything with the boat for 2 years. But that's I have this dream of finally getting that to work in my boat. But I love engines, and at Sun Labs, they recently got one of these laser cutters, and I'd been wanting one for a long time, so I had a chance to do something that I wanted to do for a while. In my spare time, I found myself designing engines that are like two-dimensional. So here's an example of one. This was sort of a test case. And the idea here is that these two brown things, they're like pistons. They can go up and down. And these are channels at different levels in the material. And if you look at it, you'll see that these open places work as valves to allow steam or water or whatever to go to the other side. And right here, this place here is where you put air or water in. So you can see that if you put air or water in this little hole, it'll go around through this opening and out to there to push this piston down, okay, which it is now. And this one, it'll also go this way and around that opening and up to here, and it'll push this piston down, okay? But when it goes down, it will change. So it's the mechanical equivalent of two flip-flops that are wired across, if you know any electrical engineering, and one turns the other one on, and this one turns that one off, and it goes like this. So I actually built one in plastic, and I'd invite you all to come up and blow on it and see it work, but I guess that wouldn't be very sanitary, but you can look at it. If you hold it up to the light, you can see the patterns. And it does work with compressed air. The problem with blowing in it is that the minute the plastic gets moist, it sticks. So anyway, just thought I'd share that. So I had this idea for a business, which is to do jewelry like this, with nice colored glass and the different layers that would be pretty, and the necklace would be the input and output of the fluid, you know. My wife told me it would never fly, and I think she knows more than I do about this. Let's see. So now we're into just the sort of pure physics stuff. I was cleaning up the yard with my son, and we got carried away with an idea. So here's. Oops. So, you know, I've been into optimization for a long time, so I thought, well, what would be better than that? And so, oops, let me close that. You notice I got him to write it. All right. Let's see. So waves. Where is the one for this? Yeah.
Yelling for dramatic effects.
Yeah. I didn't tell him to do that. And if you're interested, there actually is a YouTube video where I put 4 on the back of a bicycle. You can Google for leaf blower 4. So when Stefan showed the picture of the lighthouses, I thought that was magical. I thought he knew something about me and was doing something. This is a picture that I've been fixated on for a while, and it's a lighthouse off the French coast. And I live near the ocean, and I love to watch ocean waves spray. And, you know, I'm a physicist, and so I'm thinking that the places where you get a really good splash of a wave, they change because what it takes to do a really good explosion of water is very high pressure. And consequently, it will erode the rocks there, and very soon it's different. That's how the seacoast changes. But my thought was, gee, we could build a sculpture that's got just the right shape. It would do better than any of those rocks, and we could make it out of reinforced concrete, and it would last. So this project I have for the rest of my life is to put together enough video and experiments and stuff to get some city by the ocean to support building a really big one of these, with a whole bunch of these things, and when a wave comes in, it would go like this. Anyway, so let's see what I need to show you here. Yeah, so I looked around for hydrodynamic simulation and found this program, which was the first one that I saw that was doing the right kind of thing. It actually models what happens at the surface, and so you can get the breaking of the wave. And I thought, well, gee, we ought to be able to do that, but it's a huge Fortran program that does this stuff. Actually, there's also one in C now. And it is complicated. It is not a small, simple thing. But if you look at the rules, they're the Navier-Stokes equations, and they're not that hard, so I thought we ought to be able to do it in Squeak. And I sent a message out to the Squeak list saying, would somebody like to make this work? And nobody did. I don't know why. But that's so I gave up on that. I said, wait a minute, I could build something easier than to do this. So I did. Let's get back here. So out in my driveway, I built a wave tank. It's just a big thing full of water. And this got replaced. Actually, now I use a windshield wiper. But so this little motor pushes this piece of wood back and forth like a paddle. And at the far end is a sloping piece of wood. You need to change the depth of the water to get the waves to break. So that's the beach back there, okay? And then I did some experiments with using modeling clay. And just the intuitive idea I had was, well, if you kind of make it get narrower, that will focus the water. And if you make it go up like this, you should make the water go up in the air. And this will just show you a little bit of how it worked. You can see these waves are only about that high, but a lot of them go up 10 times that high in the air. So that was enough to inspire me to build. I built a box, and if you look inside. Sorry, I didn't have all. I've got lots of pictures of the inside, but I wanted to see if you really can get water to go up 10 times as high. And this was on a day when the waves weren't very high. It's funny. We carried this out to the beach. It's made so it's light to carry, but you can shovel sand in so that it won't go away once it's there. And some people saw us carrying this out to the ocean. And you see the rail along the side. They thought we were burying somebody. And one of them called the park service, so I had the guy come by saying, trying to kick me off the beach. But anyway, I did. I'll just show you. This just see, it actually works. And I could show you more of that, but I'm really inspired to do this. And this is a beach that I was at fairly recently. And the waves, it's not a stormy day. What it really just depends on getting a good shape of the wave and a good shape of the coast. And you can see this is it's like a 40 or 50 foot cliff and a car up there. And you just watch what happens here. Isn't that great? So anyway, I want to be able to do that, So I'm just sort of mixing things that I actually did with things I'd like to do. So let me, I'll show you, what's the best way to do this? Yeah, so this is something that combined a bunch of cool things in Squeak, I thought. See, what's the order that I want to do this? Let's do the refrigerator magnets. Everybody got some refrigerator magnets? Okay. I don't have one, but that's okay. Let me just get Squeak. So we'll go back where we were. I had fun doing this with my son's class. I go and teach in his school every once in a while. So you'd think a refrigerator it's a magnet, right? You stick it on the refrigerator and it sticks. So if you put two together, if this is north, then you'd have two norths. They should repel, but they don't. They stick. And how could that be? And so the kids are thinking like this. And then you play with them for a while, and if you're lucky, and certainly in this room, lots of people will have noticed that, especially since you're inquisitive guys and girls. What'd you find out? Okay. Yep. So they're magnetized in some form that's got both north and south, and if you take them and slide them together one way, they slide just fine. But if you slide them the other way, they go boop, 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 boop. And that's the clue. And so this is fun to do with kids because, and this is true. I think some of the hardest things to deal with in computers is state that you cannot see. Like where is the PC in this program? People like us, can do that. We're used to that. But it's not a natural thing. And so here you have to have a model of what you can't see and how that would make sense. But you can see it. And this is an instrument from the National Bureau of Standards. And it allows you to see magnetic force. And actually it's a toy that they sell by the highway for bored children. But it's got a little magnetic wand, and you can pull the magnetic filings up to put a mustache on the guy and eyebrows and stuff. But if you sort of shake it very carefully and put the refrigerator magnet underneath, you can actually see the bars. So that makes it a cool thing in a class because, the kids have sort of, yeah, well, you tell me it's that way, and then you can actually see it. So that's fun. So then I had this idea yesterday, not that one, but this one, with that wonderful demonstration of e-toys running physical devices. And I have this idea for an Arduino Ingalls mobile. And the idea is you put a refrigerator magnet down, or a whole bunch of them, and you can actually buy rolls of refrigerator magnet, stuff. And and you write a little script. So these are sensors up front, and these red and blue, that's north and south, okay? And you put the rules for if these two sensors see opposite color, then they activate a magnet that goes to these two bars. And I haven't finished the job. I didn't get much sleep last night. But you do the same thing with these sensors and those two bars, and what you're building is a linear stepping motor, okay? And so this, you can see I sort of got it working here as you slide it along there. It activates at sort of the right time, and it turns out I made the sensors too big and blah, blah. But I thought that would be fun to do sometime. And the last bit of refrigerator magnet fun I'll show you is, whoops, that's where we are already. I see. This is a wonderful system that Ned Kuntz did in Squeak. How many have you guys seen this at all? So it's it's like those refrigerator magnets that have words on them. They call it instant poetry. And you can move the things around and make poems on your refrigerator. And it's got this nice logic. If you drop that in the wrong place, everything moves out to make room. So it's really cute. And my son was getting into numbers at the time. And let me... So I had this idea for a project. And it was... So Ned Kuntz had done that. And then Luciano Notafrancesco had done this wonderful speech synthesizer. And Charlie, there's a time... I don't know, maybe not everybody does this, but I remember the time with my father when I said, well, what's a bigger number than that? And what's a bigger number than that? And what do you call what comes after a million? And so he was a a classical scholar, so he knew Latin and Greek, and he could say it goes million, billion, trillion, quadrillion, quintillion, sext, all those things. So it was nice that he could answer that for me. But in this system, if you drop this next to there, it makes a word. Isn't that nice? And so, a kid can just stay there and do this for all day and be satisfied. And so on. Yep. And you can also do. I made it so you could do this kind of thing too. So you could. Let's find. So, I wanted my talk to be not too long because we got lunchtime next, but I'd be happy to answer any questions. I need help.
As I said, that if someone wants to question in Spanish.
Good question. Who would be happy to translate that? This is teamwork here.
How do you know when to stop with your statement?
Oh. When they work or when I'm getting nothing done? And so actually that reminds me of something else. People ask me, am I done with Squeak? And no, I'm not. I mean, I got on this other channel because of where I moved to get paid and the motivation of doing stuff in the browser. But I still use Squeak. I mean, you saw some of the stuff there. And,
so then you seem to be suggesting that having experiments with physical objects is inspiration for doing stuff with the computer. Is that kind of approach practical or just inspirational? It has some consequences on education, especially because all of us who have children are having, at least I feel that I'm having more fun than them.
That's good. Yeah.
Because they are all the time with the fingers looking at some still display.
Yeah. No, I do feel that. And I think, there's no better teacher than the physical world. And, I mean, there are people who are made to, live in the physical world and people who are more into sort of social things and stuff like that. But, yeah, I do think it's real important. And, I learned a huge amount. And yes, I use the part of my brain that is excited by immediate physical experience all the time in computing. I mean, that's just how I think of it. And I remember, and as a parent, I think I mentioned this to a couple of people, but when I was a kid, it seems funny to say that, but in my younger years, I did several things that looked very destructive. So the one particular one that leaps to mind is I found out that if I put my toys on the end of a rope and swung it, they could go really fast, And then it didn't take much longer that I found that if I got them going that fast and made them intersect with something else like a wall, they'd break to pieces. And I did that with a lot of my toys. I mean, not the ones I cared about, but I used up some toys doing that. And my parents took this really well, and they were aware that I was doing Strength of Materials 101. I was learning, so I'd see how plastic broke, I'd see how wood broke, I'd see how cast iron broke, and all this stuff. And just remember, your children are all little scientists. And coming back to the nature of this experience, the physical world gives you immediate feedback, and that's what makes it so fun and so educational. And I do think that's good to give to kids. Now, for sure there are things I play computer games, and that's fun too. But it doesn't replace the other. I guess that's the thing. I don't think. Other question? Yeah.
Yes. About the work that you're doing with JavaScript, do you think that kind of user interface is going to replace HTML and CSS, or not? What's the idea?
I have no idea. There's a lot of momentum in the way people do things in the industry. And there's a lot of mindset about the way things work is that servers are here and they spit out stuff to view on the computer and all of that, which is pretty different from the personal computer notion. And so I don't have any illusions that the lively kernel is going to replace all of that. I see the lively kernel, as I think I've said, as a tool, an educational tool like Squeak, and also a tool for experimenting in the web space. That's why I made it, because I thought it would be fun to do stuff in the web. With regards to replacing things, I think the only way things get replaced is by natural selection. So if people get interested in the lively kernel and build up the same kind of infrastructure that does the kind of serious work that people get paid for in a better way, then things will move that way, yes. But things are pretty established right now. I could imagine, a picture I have for what the lively kernel could be is, the fact is, it does stuff like Flash, and it does not use Flash. And by gosh, our website runs on the iPhone, which does not have Flash. And so you could do applications for the iPhone that don't have to go through the App Store, and you could do that. And so I think there's a role there for open sourcey stuff like Flash that would run in any browser. And so there's probably a little niche there. But no, I don't think I'm going to change the industry that way. If I let, get people to have some fun, and what I really want to do is to get, and this has been hard, get more people engaged in that community, so that maybe because it's not good now. The graphics are awful. I don't have any good graphic sense, but if we got enough people together that had that sense, it might mutate into something that was actually good. Other questions? Yeah. Yeah. So it's a good question, and I don't think, to the best of my knowledge, we've never done a follow-up like that. And it would be great to get Adele to do something like that, because she had pretty direct experience with most of the students. There were a couple who were people like you and me. Bruce Horn then went to Apple and did the Finder, and he was just a natural computer guy. And Steve Putz did all the serious work on the source code management and a number of other things in the early history. They were both students. But the short answer is no, and it would be interesting. We did enough people went through that program. I think there were a couple of classes, each of about a dozen people, so there would be something to follow up on there. Yeah, yeah.
I met a guy that was on one of those programs, and he said it was horrible. He said when they took it all away, he said it was 10 years before he could do anything close to what they'd done in those classes. So he said he was very frustrated and annoyed for 10 years.
I would expect that, but I would like to know what must be.
Yeah, yeah, yeah. Yes, you had a question?
You are talking about finance.
About what? Oh, yeah, fun,
About
yeah.
finance and research. Have you ever been working in not research work? I mean, commercial, middleman, or
Let's see.
you get worrying about that? Or?
Yeah, yes, I have had jobs that were not fun computer jobs, but they're pretty difficult to compare. So I worked in a truck and equipment repair shop. I've got some great stories about that. I worked in a warehouse, and I've got at least one good story about that. And then, and I ran a resort hotel with 1,000 employees, and I've got a lot of stories about that, but that was not fun. That was a lot of responsibility. I never would have been there except that this place had been in my family for many years. So there must be a second part, you know, how do I compare those? So I tell you, I tried to start a company around this weather station I designed. So this is a weather station that reads from sensors on your roof and plots graphs over time. So it's like the old-fashioned strip chart recorder, and I tried to make it look like a strip chart recorder, but it shows everything, the rain, the humidity, the wind, all that stuff. It was a great user interface challenge. And I thought, you know, this would be a way to actually have a business and not have to. This was after I had done the resort hotel. I was thinking of coming back to Silicon Valley, and I was thinking this would be a way to not have to go back to computer stuff. I mean, except that was computers. But, and I fairly quickly decided that, I mean, it was fun talking to customers, you know, and people would give me feedback on the product, but going out to package up computers and ship them off each week, it got tired, it got boring, you know, and I had this realization that I could be making this much money doing research and doing new stuff all the time and having fun people around me. So I think I was kind of made to be in a research environment. I like working on stuff, you know, but I don't know if that answers the question. Any other questions? Okay, well, this one there, yeah. How I bootstrapped? Yeah, that was fun. So,
What was the question?
can I say how we bootstrapped Smalltalk 80? So Smalltalk 80 came pretty much directly from Smalltalk 76. So let's see, I got to remember the sequence of this. One of the things, one of the things we had to do was to convert all the source code. I'm realizing now I'm not really clear about that step. I'm clear about some of the others. Let me just get back. What's that? A C parser? No, there wasn't any C. Yeah. Yeah. Yep. So it went sort of, there was an intermediate step, which was Smalltalk 78. And what we did was, I got this. So we got, Smalltalk 78 was like Smalltalk 76, but with a replaced object memory and a simpler virtual machine. And that was, I think I said yesterday, that Smalltalk 76 had this virtual virtual memory and a hashed object table and all this stuff, and lots of primitives to do windowing and line drawing and all that stuff. And so for this small computer, we replaced all those graphical primitives with just bitblit, because that was running then. And we did another virtual machine that was just that used the direct object table. And then we got that running out on the Alto, and we changed some fairly major things. The thing that was the hardest to change was how blocks worked. Although as soon as we got clear about it, it wasn't hard. So we had this thing called the vmem writer, which is now the system tracer, I guess. Yeah, and it could write out a new copy of the whole system. And so we started making these various transformations into the new image format, and they gradually started to work. You know, the first thing we worked on was getting the first method, which is the method where you save, and you get that to work, so it starts to continue on from there. And we just kept iterating on that process until everything ran. So what we had then was a system that ran, but the source code wasn't right. So then we had a decompiler, and we rewrote the decompiler to work, you know, because it was broken then. And then that let us decompile all the sources, except that I can't remember if we lost the comments. There weren't a lot of comments, or whether it handled that. But that then got us pretty much bootstrapped. I don't know if does that answer your question?
The VM was already in assembly?
Yeah.
Microcode?
Yeah, it was a mixture. And for Smalltalk 80, we got all of it into the microcode. For Smalltalk 76, we didn't, but we got the hash index into the object table and the inner loop and just a couple of the bytecodes in microcode.
Yeah. So why do you think we don't have microcode anymore to use and use or intermediate use?
Well, I don't know. It's everything runs so fast that it doesn't matter much.
Faster, right?
Yeah.
Everybody's still trying to make everything faster. So.
Yeah. And I guess so. People just don't do So cache has kind of served the purpose of microcode, because stuff that's in the cache runs that much faster. And if it's not in the cache, it really does run slower. And I guess, you know, an analogy possibly to the situation with microcode might be a computer in which you have FPGAs that you can put primitives in. Yeah. Right. Yeah.
But you have some space in the hardware that will run the virtual machine, right? So it will be a sort of small microcontroller. You tried that, right?
Yeah. Well, so we did write microcode so that made it like a Smalltalk machine. Yes. I haven't gone as far as some people have in that direction. Especially Dave Unger's work was pretty neat. But yeah.
What do you think of Mozart today? Are you happy with Mozart as a movie, or maybe you change your mind? What's your impression about that?
Well, I'm delighted to see what people here are doing, and you know, there's plus and minus about stability. I mean, a lot is the way it used to be, but that's good because you can build on the past and share libraries and all that good stuff. But there are also things in the future, and I think I mentioned yesterday that the big thing that I think is going to change in the future is experiments like Newspeak, dealing with some of the security issues. But trying to do it and still keep things simple. And I'm convinced that you can do things as simply as we're doing them and have them secure, but I haven't seen anybody do it. I mean, I have trouble with Newspeak and as a nice language to read. But it's got some really strong points, and I felt the same thing about E. So you asked me what I feel about it. So I think it's great. I love to use it. I'm really glad it's there. I'm really glad people are doing fun things in it. But in terms of a movement, I think the next thing to do is to look around at how that kind of thinking would like to grow in the context of the web and in the context of multi-core computing and all that stuff.
You just mentioned security again, and I also think it's important, but I'm struggling to give good examples of why it's important.
Of why it's important?
Yeah, what can you tell about it?
Well, I think of it again in terms of survival of the fittest, and this scenario I mentioned yesterday. If you imagine that the Python community came up with a provably secure system, and people started doing web applications in it, I think there would be a big movement in that direction, and in that sense, we would have missed the boat, And I think it'd be fun if we did experiments like that and showed that, hey, look at this language. It's been around for a while. Nobody thought it ran that fast, but it can run fast. And guess what? It's provably secure. Look at this system. Try to break it. and then we would be driving the boat.
Yeah, I agree. I absolutely agree. Actually, I forgot to mention that one. But that was one.
Yeah.
Then the context is the web, or a more connected world, or peer-to-peer, or live code, or what context?
Well, I don't know. I mean, actually, I'll be honest with you. You're talking to somebody who doesn't care about security. I'm sorry, it's my fault, but I was born that way, and I'm much more interested in seeing what you can do if everybody trusts everybody. But I think there are places where that kind of thing matters, But I'm not convinced that it's solvable either, and that may be where you're getting at, because certainly there are a number of attacks, and there's a wonderful. If you go to that site on Kaha and Kahita, there's a wonderful web page there where they've got like 20 or 30 known attacks on JavaScript. And how to try and deal with them, here's the problem. I think a capability-based system really is a good answer to this. It's much more provably secure than some of the other systems that say they're secure. But there still is the problem. What if somebody comes in and replaces your hardware with something that emulates everything just the way it was, but ships stuff off somewhere. And I don't know how to answer that. It's a spy versus spy story, and it's in a space that I'm not good at really. So I think you're probably going to come up with the answers here. I'll take one more, and then I think it's time to quit, and we can chat offline. Yeah. What do you mean? People love it. They just never get to see it.
Let's see.
They get introduced.
More statistics. Raise your hand.
Who likes keywords? See? No, I don't know. There are assumptions in what you said. These are people who have been introduced early on to parentheses and commas and stuff like that.
Objective-C helps.
Yeah.
You've got a whole generation of people learning keyword syntax again
Yeah.
they don't seem to be put off by it.
Yeah.
But it is that there is no natural selection like in biology in our life, because people putting money, they are interesting, you have monopoly. So
Right.
Well, that's
I believe in natural selection, but our life doesn't work like biology.
So, well,
There are all these things around.
it's just, well, it's a bigger view of natural selection, you know, and so check back in 100 years, you know. So I think we'll stop there, and I want to repeat again, this is exactly why we did Small Talk and Squeak, and it's been a huge pleasure for me to meet you all and have a chance to come see your beautiful country. So thanks.